Okay, so binomial distribution is a distribution that has the following properties. Number one, bi means two. So there are two possible outcomes. There are two possibilities, a success and a failure. Then the other property for binomial is that each event has an equal chance. So there's equal chance of occurrence. There's equal chance of occurrence. So they occur equally. So if an event, please make sure you mute your mic so that we don't have background noise. So if the events are sampled, each event must always have an equal chance of being picked. So there's equal chance of occurrence. Then finally, events occur independently. So a binomial distribution, you're able to tell if these characteristics hold. So there's independence. Now, whether I've taught you combinations and permutations or not, I want you to understand this in its simplest form. There are only 4 formulas you need to know. So the probability of X is simply given by a combination of n combination X, n combination X, then the probability of X, probability of P to the power X, and probability of 1 minus P to the power X, to the power n minus X. Okay, other books will simply put Q there. So we have the formula for the mean given by n times P. That is the mean. And we have the variance given by n PQ, n times P times Q. And the standard deviation is simply 1 square root n PQ. Now Q is simply 1 minus P. So let me just take you back briefly to combinations. If you are given 5 combination 3, it will look like this here. You go on your calculator. What is 5 combination 3? It will give you 10. 5 combination 3, it will give you 10. Now, how do I find 5 combination 3 on a calculator? How many have a Casio calculator?
I have sharp.
Okay, let me start with the Casio calculator. So for the Casio calculator, which is the most basic calculator and very easy to calculate. So if you're using the Casio calculator, you're going to go press 5, then the combination is there, then 3. Do that. Let's see what is 5 combination 3. 10, right?
10.
Okay. Try to find 10 combination 3. Let's see.
Say that again.
10 combination 3.
Combination 3. 120. 120.
120, good. 120. So I need you guys to learn how to use that computer. Those that are using a sharp, the sharp looks like this. So if you're doing combinations for the sharp, the combination is on this button. you find where it's written NCR. So the sharp, can you see where there's NCR? So you're going to press 5, then shift, then 5 again, then 3, then equals, because in yellow there's something written NCR, which is N combination R. So you press 5, shift, then 5 again, then 3. It'll give you 10. Those using a sharp?
Wait, just a minute. You can start again. NCR.
So 5, combination 3. So you press 5,
5.
then the combination is on the 5 in yellow there.
Mm.
So to find anything in yellow, you press shift.
Mm.
So shift, then 5 again, so that the C comes. Then 3, then equals. What do you get? 10?
10, yes.
Okay, now find 10
So you
combination.
press 5 twice?
Because you are pressing 5 because that's where the combination is. So try 10 combination 3. You go to 10, shift, 5, then 3 equals. Because we're shifting 5 because that's where the combination is. So 10 combination 5, what do you, combination 3, sorry, what did you get? Ten combination 3, what are you getting?
1050. 1053.
Not 120. Try again. 10, shift, 5, 3 equals.
Okay. Okay. 10, shift, 5, then 3, then equals 120. Okay.
Exactly.
Yeah.
Okay. So now, if you don't have a calculator, I want to teach you how to find combination without a calculator. You draw what is called a Pascal's triangle. It starts with 3 ones. So you do this, 1, 1, and 1 there. So 1 plus 1 is 2. So we add 1 plus 2 is 3. 2 plus 1 is 3. Then you close with 1s there. Then again we count. 1 plus 3, what do we get there? 4. Then here what do we get when we add these two? 6. Then here what do we get? 4. Then we close. Now let me choose one of you to continue. Mutinta, continue for us here. 5. Then Moses, Mutinta and Moses. 10. Then who wants to help them? Mlenga, Mwamba. 10. When you add 4 plus 1, what do we get?
5.
5. Then we close.
Which ones again?
Then what do we have here now?
6.
Uh-huh.
Then 15.
Uh-huh.
20.
Uh-huh.
And 6.
15. Then 6.
15, yes, 15 and then 6.
Okay, again, let's try again. The last one. 7.
7.
21.
21.
35. 35. 21. 7. Then we close with 1s. Now this, how does it help us? What does it help us do? It helps us find the combinations. So what is 5 combination 3? You go 35 there. You count 1, 2, 3. So the answer is 10. How about 5 combination 0? Any number combination 0 is 1. So 5 combination 0 is 0. 5 combination 5 is 1. So any number combination itself is 1. 5 combination 4. So the second last number of the combination of any number is itself. So 5 combination 4 is 5. Let's go to 6. Can somebody tell me what is 6 combination 3? 6 combination 3? 1, 2, 3. So what is 6 combination 3?
20.
20. Confirm on your calculator. Confirm on your calculator. Is it 20?
Yeah, it's 20. Yes.
All right. What is 6 combination 6? What is 6 combination 6? Even without using a calculator, a number itself is 1.
1.
About 6 combination 0?
1.
Any number
0.
combination 0 is 1, right?
1.
Yes. Okay, what is 7 combination 3?
35.
Good,
5.
35. 1, 2, 3, 35. About 7 combination 2? 21, yes.
21.
How about 7 combination 1?
7.
7. Any number combination 1 is that number itself. 7 combination 1 is 7. 7 combination 6 is 7. 7 combination 7 is 1. 7 combination 0 is 1. So now with this pattern, can I ask you, what is 100 combination 99?
100.
100.
Good. How about 100 combination 100?
1.
1.
1. Yes. How about 100 combination 0?
1.
1.
Even 1 again.
100 combination 1?
100.
100. Excellent. So with that being said, I don't want you to abuse the calculator. So some of the things I want you to in your own brainwork, try that. So binomial is the simplest probability distribution. So suppose we have our n is 7, our probability is 20%. So they'll ask us, number 1, find the probability that x is equal to 0. Find the probability that x is equal to 0 or 1 or 2 or 3. Then part B, find the probability that x is at most 3. And finally, find the probability that x is at least 2. That is part C. Probability x is at least what? 2. So here, for you to be doing your master's, you must have understood or passed English at least. So you need to understand this grammar. At least means what? If you skipped grade 1, I'll repeat. So let me start with x is equal to 0. So we already know that x, the formula for binomial is that it will be n combination x. Then here we put the letter p here to the power x. Then here letter q to the power n minus x. Okay, so our n we know is 7. Then our x has been given part 1 as 0. So here we put 0. Then the probability is 20%. So 0.2. Meaning if probability is 0.2, meaning q must be 0.8. The two must add up to 100. I told you that p and q are like they add up to 100. So if P is 20%, Q must be 80%. If P is 10%, Q must be 90%. So A is 0, rise up. Then the difference 7 minus 0 is 7. Remember here it says the difference n minus x. So the difference there, that is what makes the power. Even this Q is a difference, 1 minus P. So without using the calculator, what is 7 combination 1? Oh,
1.
7 combination 0. What is 7 combination 0 is 1.
1.
What is 0.2 to the power 0? Any number to the power 0 is 1.
Yeah.
Then what is 0.8 to the power 8? 0.8 to the power 7, what do you get?
Well, we better smoothly fly ourselves to a market. We're out of food. Guys, wait.
Quickly.
0.2097.
So when we multiply everything, we get 0.2097. Excellent. That's the final answer. Now, Phyllis, lead us through x is equal to 1. What do we do?
We put up the formula. Okay, where you are. Our n is 20. I mean, is 7. Then our x is 1. Our success, which is p, is to the power 1.
What is our p? 0. What?
Or rather, our success is 0.2, since it's 20%.
Meaning our failure is what?
Our failure is 80%, which is 0.8%.
So what do we put on top of the 2?
1.
And what do we put here?
That is 7 minus 1, which is 6.
The difference, right? Because when you add this
Yes.
and this, it must give us what? 7. Okay. So what is 7 combination 1?
7.
7, good. What is 0.2 to the power 1?
0.2.
0.2, good. And what is 0.8 to the power? 0.8 to the power 6?
0.26.
26 what? Leave it to 4 decimal places.
262. 2621.
The final answer, when we multiply these three, what we get?
.3670.
3670. Good. Excellent work, Phyllis. Felix, pick on anyone to help us on the second part. X is equal to 2. Pick on anyone.
Hilda.
Hilda. Okay, Hilda. What do we write here, Hilda?
You start with 7. And then 2.
7 combination 2.
7 combination 2 times 0.2. To the power 2.
Times here 0. What? What is the failure?
0.8.
So what do you put here?
So there you put 2.
Then here?
And then 7 minus 2, which is 5.
Good.
5.
Then what is 7 combination 2?
It's 21.
Okay. Then 0.2 squared.
That's 0.04.
And 0.8 to the power 5.
That's 0.3276.
And the final answer?
Give me a second. $0.275.
Excellent. Pick on anyone to lead us in x is equal to 3.
Kasonde.
Kasonde. Uh-huh.
I pick on Yamikani.
Okay, Mikani, you've been repicked. Uh-huh.
Okay, so we start with 7 combination 3
Uh-huh.
times 0.2 to the power 3
Mm-hmm.
times 0.8 to the power 4.
Excellent. Uh-huh.
Let me just compute. So 35 times
Mm-hmm.
0.008
Mm-hmm.
multiplied by
Mm-hmm.
0.4096.
The final answer?
Final answer is 0.1147.
Great. I'm so happy. What you should not get is 1 point something or negative, because probability must never range within those figures. And can I thank you? Now, what does at most 3 mean and at least 2 mean? Anyone who passed English here? At most 3 means what?
Should not be greater than 3.
Okay. Good. So at most 3 means 3 and below, right? 3 and below.
Yes.
At least 3 means 3 and above. How about less than 3 means what? Less than 3 means what? Starting from 0, 1, and 2. Don't include the 3, right?
Yeah.
Good. I'm shocked this group understands English. I've been struggling with the other BID groups because I have to start English and verbs and proverbs. So now, at most 3 means 3 and below starts from 0. So meaning, this means that we are adding the probability of 3, 2, 1, and 0. So what's the probability of 0? We already calculated it, right? The probability of 0,
Yes.
0 was what? 0 point what? 2097. Then what was the probability of 1? 3670.
0.3670.
Then probability of 2? 275.
0.275.
And finally, probability of 3?
0.1147.
Okay. So 1147. You total them up. What do you get? What do we get? What's the total? Please, in the interest of time, be quick.
0.9667.
Okay. So probability at most 3 was
9667.
0.9667. All right. Now, at least 2. Can somebody remind me? What did we say? At least
I'm
2.
finding 0.9664.
9664. Okay. Anyway, the difference is negligible. 4 and 7. It's okay. At least 3. What does at least 2 mean?
Not more than 2.
Are you sure?
Not less than 2. Not less than 2, sorry.
Yes. At least 2 means 2 and above. It means x is greater or equal to what? Or
2.
equal to 2. So we're looking at which figures? Starting from what? 2
2 and 3.
and 3.
And 3.
And what? Up to the last number n.
Or 4,
Up to what?
7.
Now this will take you the whole day to calculate. All right?
Yeah.
So the shortcut, we know that the probability from 0 to 7 must give us 1. So the shortcut is simply 1 minus the figures that are not listed there. Which numbers are missing there? The numbers before these 2.
4. Yeah.
0
1,
and what? And 1. I repeat.
0 and 1. Yeah.
If you're told at least 2, we are looking for 2, 3, 4, 5, 6, and 7. The shortcut just do 1 minus the unlisted numbers. So 1 minus 0 and 1. If it was at least 4, we're talking about 4, 5, 6, 7. But the shortcut is 1 minus 0, 1, 2, 3. Do we include the 4? No, because the 4 is part of the listed figures. Are we together?
Yes.
So you need to really understand that. But how do we know when to subtract and when not to subtract? Just know where it's easier. If there are 10 of them and you're told at most 8, it means 0, 1, 2, 3, 4, 5, 6, 7, 8. Even that one is cumbersome. The shortcut is simply 1 minus the probability of what? 9 and 10, the numbers that are not listed. So it's not always that when they say at most, it's a must always subtract. No. Even if they say at least 9, it means you're looking for 9 and 10. Just find them and add them up. Right? So I only have a minute to go. So let me also finalize on the mean. How do you find the mean? The mean is NP. The mean is NP. What was our N? Our N was 7. What was our P? 20%, which is 0. What?
Yes.
0.2. So here we get 1.4. Okay. Then here our variance. Our variance is NPQ. NPQ. What is our N?
7.
7. Good. And what is our P?
0.2.
0.2. And what is our Q?
0.8.
And what do you get as a final answer? You calculate
1.12.
1.12. Then how do we get our standard deviation?
Square root.
Square root of NPQ. So the square root of what? 1.1, 1.1.
127.
What do we get?
1.061.
1.0616.
616.
Excellent. So at this point, I'm very comfortable we're able to do binomial distribution. So I'm going to give you a class exercise or class homework just on binomial distribution. Unless there are any questions, you can ask. So I'll give you some class exercise. Then I'll give you about 15 minutes before we start managerial economics. So we're going to end here. Thank you so much for your time. I'll send the homework in your respective groups. Please
Thank you.
take your time. Have a good evening. 15 minutes, we start
Thank you.
managerial economics. All right.
Thank you.
Hello, Collins.
Yes, please.